Hey everyone, in this video we are doing the classic question of a ball being dropped off a cliff every time it reaches a certain percentage of its previous height. We want to know when the ball is 5 centimeters, how many bounces has it been? So we are going to use actually the same formula we use for doubling and half-life. So we've got the question, a ball is dropped from a 5-meter high cliff. After every time it bounces, it's 80% of the previous height. So how many bounces has it been when the ball is 5 centimeters off the ground? So A is how high the ball is now. So that would be 5 centimeters. A naught is like the height of the cliff the ball was dropped off of. We were given 5 meters. We can't have centimeters and meters in the same question, so let's convert 5 meters to be 500 centimeters. C, we know that each time the ball is 80% of its original height or its previous height. So always write percents as decimals, so it would be 0.8. T, we don't know. We want to find out how many bounces. T is the number of bounces. P would be, it is 80% of its height after each bounce. So each bounce means 1, so P would just be 1 in this case. So I won't bother writing in T over 1 because that's just the same as T. The first thing I can do is divide both sides by 500 because the 500 is not connected to this variable in any way. 5 divided by 500 would be 0.1, 0.01. 500 divided by 500 is just 1. And then I've got 0.80 to the exponent of t. Well, let's take the log of both sides. Log 0.01 equals power rule of logs. So it'll be t multiplied by log 0.8. Let's divide both sides by log 0.8. Divided by log 0.8. Those will cancel out, and I'll get t equals log 0.01 divided by log 0.8. If you don't see the base written, assume the base is 10. That's what your calculator assumes too. So I'll just stick that in my calculator, and I will get 20.6. 20.6 equals to t. So we can't have, a decimal. We want number of bounces. So we've been potentially getting some rounding error or something like that. So let's round that up to say at 21 bounces, after 21 bounces, our ball that was originally dropped from a height of 500 centimeters or 5 meters is at 5 centimeters of height in this bounce.